The starting point for all transmitters is carrier generation. Once generated, the carrier can be modulated, processed in various ways, amplified, and transmitted. The source of most carriers is a crystal oscillator. The equivalent circuit for the quartz crystal shows an RLC series circuit, which represents the mechanical vibrations of the crystal, in parallel with a capacitance, which represents the electrical connections to the crystal. The only oscillator capable of maintaining the frequency precision and stability demanded by the FCC is a crystal oscillator. A crystal is a piece of quartz that can be made to vibrate and act like an LC tuned circuit. Overdone crystals and frequency multipliers are two devices that can be used to achieve crystal precision and stability at frequencies greater than 30 MHz. Hallquist-type crystal oscillator is the most commonly used crystal oscillator. Feedback is derived from a capacitive voltage divider. Transistor configuration is typically an emitter follower. The output is taken from the emitter. Pulling or rubbering capacitors are used to make fine adjustments to the crystal oscillator frequency. Field effect transistors make good crystal oscillators. The Pierce oscillator is a common configuration that uses a FET. The term harmonic is often used as a synonym for overdone. If the transmitter must operate on more than one frequency, but crystal precision and stability are required, multiple crystals can be used, and the desired one switched on. Mechanical rotary switches and diode switches are often used in this kind of application. Diode switching is fast and reliable. Frequency synthesizers are variable frequency generators that provide the frequency stability of crystal oscillators, but the convenience of incremental tuning over a broad frequency range. Frequency synthesizers provide an output that varies in fixed frequency increments over a wide range. In a transmitter, a frequency synthesizer provides basic carrier generation. Frequency synthesizers are used in receivers as local oscillators and perform the receiver tuning function. The phase-locked loop consists of a phase detector, a low-pass filter, and a VCO. A direct digital synthesis synthesizer generates a sine wave output digitally. The output frequency can be varied in increments depending upon a binary value supplied to the unit by a counter, a register, or an embedded microcontroller. A read-only memory is programmed with the binary representation of a sine wave. These are the values that would be generated by an analog-to-digital converter if an analog sine wave were digitized and stored in the memory. If these binary values are fed to a digital-to-analog converter, the output of the digital-to-analog converter will be a stepped approximation of the sine wave. A low-pass filter is used to remove the high-frequency content, smoothing the sine wave output.